Hi everyone, my name is Jake Venzel, and this is my presentation for my major assignment, Part A1 for Jimmy Lawrence's Heat Mass course at LSU. So much for your time. So the question that I had to answer was threefold. The first one was asking me to find the length of time required for the center temperature to reach 425 if its surfaces are raised and maintained to 425 Kelvin and 600 Kelvin. The second question was asking me to plot the temperature change over time and determine the total time that it took. And the part three was asking me for a 2D or and 3D system, what should the stability criteria look like for the systems and why would they look like that? So these are three formulas that I used when solving for the actual parts one and two. And you're going to see how they come into effect with my code right here. I first defined all my variables and imported the matplot that I used to help put in some of these values in my code. So I defined my variables and then defined my overall formulas that I would use in the loops that I would make. I then defined for list total in order to hold the values as I went through my overall code to hold the values and then reinitiate them as the steps were progressing. Uh, and this would allow me to make the overall graph better and more accurate rather than doing a bunch of tedious steps the loop to simplify the process and make it go faster. Um, so I have my first loop where I embedded it, and then I then embedded the second loop or the first loop into the second loop, which I then went all the way down and printed out the values in order to make sure that I was getting an accurate uh, graph as well as the accurate values for the time and the overall temperature and the center. And overall, I managed to get a value of roughly 17 hours. I got 17.02 hours total, and I found that the temperature at the center was 425.02 Kelvin. And this is the overall graph that I managed to make using the Python code and the data that was given to me. And as you can see, pretty strong peak going up from 0 hours to 17.5 hours or almost 17.5 hours. And this coincides well with the data that I managed to find for my answers to the questions one and questions two. So for question three, I managed to find a correlation between the 2D and 3D systems, and the correlation is should be such that it requires the uh, TM initial in the TMI plus one expression to be greater than or equal to zero, and that due to the limits in the size of the time step that can be used, it actually limits the time step that can be used when calculating and using code as well. And for example, in the case of a 2D heat transfer, the coefficient of the TMI in the TMI plus one expression, in this case, would be 1 minus 4 tau. And that due to what I stated previously, in the case of this relationship, the uh, the expression would then equal 1 minus 4 tau greater than 0. Thank you so much for your time. If you have any questions, feel free to email me at jvency1 at lsu.edu. And thank you so much for your time. I appreciate it.